it. Yeah. Okay, guys. Thank you all for joining on Saturday again. So now moving on here, we were discussed about some few conditions like, after flowing up this complete geometrical flow directions that what we are solving it. We have discussed a few things like when to choose the K-work procedure and when to choose the gravity loading conditions. And then we have just moved that like when to choose the flow conditions like a steady state groundwater flow conditions. And then we were discussing about like if you are worried about the thermal analysis, what is the importance of an earth gradient and what kind of a parameters that you need to consider it. And then I was talking about this steady state thermal flow boundary condition also. That's where like when you're creating, when you would like to assign this. Yeah, I think this is where actually my cues indicating me this is where I stopped it exactly. So now if you just look into this actually. So we were discussing about this particular step and it is called as a Newton-Raphson method and we have seen that. And after that, when you just go over here also, we have just seen that when you are running any problem, what are the values that you need to see this. So the sigma in stage indicates that this is what it has happened it and stiffness, it is reducing it. This is also we discussed it. Yeah. Now a little step we can go a little forward now today. And today that what we are going to discuss is like the phase construction structure actually. Okay, so this is a very important thing. This is not just about the structure that what you are going to build. I mean today the step-by-step procedure, it also defines the flexibility of doing a multiple iterations. Remember that it also shows you a flexibility of running a multiple different iterations. Yeah, example, I'll tell you this. When you just initial phase actually, which is automatically coming, and that is where like in the initial phase, what kind of things that we need to fix, everything that we have discussed it over there. I got a notification. Who is John? Okay, fine. No worries. Okay, so we got this in initial phase and we understood this is like a first phase and what are the things that we got to do. Next, immediately followed with this particular first phase, if you see that arrow, it is coming down and then you are doing this particular active lines and all. So now in this actually what will happen is like apply the line load is what actually it is telling that. And then next it is like a first phase, whatever the first phase results it is coming, that particular first phase results will be there. Addition to that, it will apply the line load to this particular results. Okay, I mean, whatever the analysis is already done at the phase 1 or the initial phase or the first phase will carry forward to this particular active line load. And now when you just go for an active displacement, after applying the line load, whatever the settlements is there, on that settlements you are applying a displacement. That is what is actually the meaning of it. So this is an initial soil layer, on that you applied a line load. After applying the line load onto the initial soil layer, there is some deformations. On that deformations, if you are applying a displacement, this is what actually this indicates it. Suppose if you just go for this kind of behavior, like this is an initial phase, and to the initial phase you activated a line load. That means after the initial phase, it till this particular step and this particular step it is same. But here what it is happening, after applying the line load, there is a settlement or there is a deformations coming. On that deformations, we are activating this particular active displacement, right? But here actually what will happen, this indicates that after the first phase, again I am doing an active displacement. And that means I'm neglecting the results of the line loads and all. Maybe someone please take care about to admit the guys. Okay. Now,
can anyone give the permission to admit?
Whoever there in the class, anyone can admit it.
Okay, I will help out. No problem.
Yeah.
I'm
Okay.
comfortable
So
with that.
this is where like actually you can able to go ahead. Like this is what is the meanings of this particular phase constructions that it is telling you. Like now, if you just see this one, open a project, and if you just go and open this particular project, Now you are just going for this particular stage construction and you have selected all the things that whichever it is required, everything. Now you are like adding a one more phase, and to this particular phase you are telling that you are activating the line load and the line load that you are activating it. That's it. Okay. And now on this actually if you add a one more phase, this is where like a phase 2, and in this particular phase 2 you are activating only the line displacement. That means now in this analysis first it will calculate the pore pressures based upon your initial soil conditions, and then on that pore pressure conditions, if you are applying a line load, then this particular line load will activate over here, and then it will calculate the results. After deformed soil, again you are applying a displacement. That is what actually it is telling you. Suppose this is not the case, the initial phase it is there, you would like to add phase 1. Okay, this actually I would like to add only the line loads. And now this is a phase. Again, I will click on this an initial phase, and now I'm adding another phase. And this particular phase, I will say that this particular thing is like line displacements that I'm adding here. Now you see this. Don't be get confused. It is very simple. Just try to observe it very carefully. And okay, the moment now you build so many structures and you got confused yourself, don't worry. Here, if you just double click on this particular phase 1, for the phase 4, the input is like initial phase. It is clearly telling this. But if you double click on this particular phase 2, it is telling that the phase 1 is an input. Okay, suppose if you click on this particular phase 3, you would like to give phase 2 as an input. Now you can just simply drop down and you can just give phase 2, then automatically the connections will change here. Okay, so whichever be the comfortable one that you can go it. For example, I can tell you that you have like a simple soil, whereas you have applied force in one conditions, and whereas you have to recheck the same problem by applying the displacement and you are getting the same force or not. So that particular reiterations that if you wanted to do in this particular cases, actually this flow will be helpful for you. And not only in this, if you would like to do some multiple iterations, multiple cases, you can name so many scenarios actually, which I would like to study it back from the particular cases, and then particular time what would be the behavior if I just wanted to see. So in those kind of analysis that you can able to do it over there. Did you understand the links between these two, how it is indicating? Any questions on that?
It is not the question. Previous stage is becoming the, let us say, basis for second next stage.
In this case,
2 becomes 1 becomes the input for the 2, and 2 becomes input for 3, and like that.
yeah, if
So
the
every
arrows are
stage has a input link with the previous.
yeah, if the
What
arrows
is
are like
understood.
this, if the arrows are like this, but here,
Okay.
but here if you can see this, the input for phase 4 is like initial phase, because the arrow it is showing like this.
Basically, it is a connection.
Yeah. Okay, so this connection you have to play it cleverly based upon your realistic situations. How well you have to simulate it in realistically, that well that you can able to bring up this particular connections, and then you can do that. Yeah. Next, connection symbols also that you need to be very careful about this. So you will come to know by looking into this here and there that you have it. So when I just go for this, I don't have more flow conditions. Let me create one flow conditions here.
Can I ask a question?
Yeah.
So the connection of 4 to initial and 3 to 2, 2 to 1 is by the system, or we will choose?
We
If we
will
have to
choose.
choose,
We have to choose.
so what will be the criteria? Will you please repeat? I missed that.
Okay. Don't think complex first of all. Make your brain very, very simple. I'm telling that because this is a very simple solution. People try to understand it in a more complicated way. Don't go in that. First thing, actually, I have a soil. Let's say going here
Correct.
itself. I have a soil. When there is a soil in my land, don't think about the software. Now you are walking onto your site, and in the site that you have seen, there is a complete empty soil. but due to some earth gravity pressure and as well as some water pressure inside this particular soil, there is some default pre-pressure will be there. That's all we are calling it as like a pore pressures, right? So now in the initial conditions that you are calculating all these particular pore pressures. Okay, now on to your real site. Now you start constructing something. When you start constructing something, what is the input for that? First, you already have a soil at the base. Over that only you can start constructing something, right? So that means your initial phase is your soil. Over that, whatever the construction that you are building it, that is like phase 1.
Okay.
Now, over that particular construction, you want to apply some particular force. That is phase 2.
Okay.
Over that particular force, you want to apply some dynamic behavior. That is like phase 3. That means first you are constructing it, you are applying static force, and then you are applying a dynamic force.
Fine. So in the light of
now,
dam, dam, we
now
can,
in this case, actually, now you realized it by doing all this particular analysis. In the dynamic analysis, it is getting failed. Or
so
during
always
static
dynamic
analysis,
cases will be there.
Again, don't complicate your things. Just assume this. Okay, maybe I'm giving you some more technical words. That's why you are complicating yourself. Let me go in a very simple layman technology. You have a sand. There you are there you put one brick. Over the sand, you put only one brick. And again, by considering that particular one brick, you want to place a one more brick. That is like, I'll just go with the diagram only so that you can understand it.
No. This is it. What it will. Okay.
Does our diagram exist? Yeah. Oh, no. Okay, let me go this delete file import from okay, now we can use this Wikika advantage. Just going here, let's go to this wiki. I have something here. This is the latest diagram that I have it. So now save niche as maybe onto the desktop. You can say it's like items of PNG. Okay, and now moving here, we can just go file, import from device. Okay. This is how actually you can get back your images to at any point of time. Yeah. Now, what we are discussing is about like the stage construction, right? So when you just wanted to do about this particular stage construction, let's say that you have this list. So where in this particular list that you are going to do this like initial phase, and then you have like the phase 1, and then you have like a phase 2, let's say, and then you have like a phase 3 also. Okay, this is where actually, yeah, this is what actually you have it. Now onto this particular thing, this is your initial soil layer. You can just go and number of soil layers or whatever it may be. This is your soil layer that you have it. So this particular soil layer is being this particular soil layer is representing you the initial phase. Actually, this particular soil layer is representing you the initial phase. And now again the arrows will confuse you. Yeah, the soil layer is indicating you the phase 1 connection. It is very clear. Now actually what you are trying to do, you are trying to build one particular construction on this, either it's a foundation or anything, whatever it may be. You're just trying to put something on here. So and now in the something is like some you can say some foundation you have placed it. Okay, if the foundation, if it is placed it, and this particular thing here, actually I'm just going to call this as like my phase 1. So I have an initial phase, and then actually I'm just going to construct this as a phase 1 now. Now onto this, actually what you are trying to do, you are trying to apply some kind of a load. You are trying to apply some kind of a load. You are trying to apply some kind of a load. And now this particular thing that you were trying to activate it as like a phase 2. So this particular load actually, you can say this particular load is like phase 2. That's what you are trying to do this. So now the phase 1 is connected to phase, initial phase is connected to phase 1, and then the phase 1 is connected to phase 2. This is a one particular scenario that you got it. Okay. So this is a straightforward connection, and this particular connection is similar to that of what this sort of connection is similar to that of like what you have seen here. This is actually belongs to this particular thing. This is what actually you have seen it. Now what happens is like the same soil, because of some reasons that you wanted to do some kind of analysis in a more and more iterations that you would like to do this. Now what happens is like, this is like a foundation, it is there, this is the load, everything it is there. Now I don't want to do this one. I want to build foundation and then I would like to apply the load, right? So but now actually what I want, I directly want to build phase. This I don't want it now. So that means soil layer I have constructed as an initial phase, and then immediately I'm constructing only the load actually. So I'm not building the foundation at all in this particular cases. So now you have a chance to study with the same geometry, same mesh without going anywhere. You have a feasibility of studying soil layer with foundation and with load in this particular phase. In the same file itself, no need to move to the other file. You are creating a one more phase, and that particular phase you are calling it as like automatically it is going to name it as like a phase 3. Now the soil layer will be the base phase. Over that you are creating a one more phase, that is where you are trying to apply the load directly. You are trying to apply the load directly, and in this particular case the foundation will not be there. So I can just eliminate this. Foundation will not be there at all. So that means this particular phase 1 will not be there. So this kind of a scenarios actually we calling in this particular way. That means phase 1 and directly connected to only the active displacements that we have it. So we are not having this active line and all. So yeah, this is where is this particular thing that you have it. You understood in this particular phase, the phase 1 is like nothing but your initial conditions. The phase 1 is nothing but your initial conditions, initial phase, and the active displacement is nothing but your phase 3. But in this conditions actually the phase 1 is nothing but the initial phase is nothing but the soil layer, and then the active line is nothing but line load is nothing but your phase 1, that is where like some foundation or something you are doing it. Okay, and then the next one is nothing but over that again you are activating the displacements over here, or like over that you are applying the line loads over there. Now you got some clarity? No.
Yeah.
Remember this, if you are a well player of this, you no need to do this model separately and no need to do this model separately. You can combine together in a one single Plaxis file. You can able to do this. Advantage, take the advantage of the software. Is that clear to all? Don't be get confused, because in the coming up problems you will end up with 100% questions if you didn't understand this particular question, and you cannot able to solve the complex problems if you cannot able to understand this particular links. Yes, no, understood or
Yeah,
no?
yeah, I understood.
Okay, fine. It's from everyone. Okay, I take your silence as S and then moving.
Yes, yes.
Yeah. So moving next, actually, in the initial conditions itself, you have to do some kind of a boundary conditions. Okay, so this particular boundary conditions will vary from analysis to analysis. That's where I need to discuss about the type of analysis also with you. Okay, so if you just go for this particular problem alone, and if you just go for this particular meshing or something like wherever you just go for this, and if you click on this particular view mesh, I cannot show the mesh before it generated. Okay, the mesh is not generated, it seems. Okay, I'll generate the mesh. And if I just click on this particular view mesh, materials you can show, element contours and element numbers is not required. This is the loads actually, and you can say this is geometries and fixities. You can see this. This is what actually other softwares you have to do it, or you have to give it manually, but Plaxis will understand this very easily. Automatically it will understand this. Not only for the static analysis, even it understands very well for dynamic analysis also. It will understand very well for dynamic analysis also. Okay, so you have to be worried about this particular boundary conditions. So the boundary conditions is like, when I apply a soil on this, as in reality, if you say what is the distance that you have it, it is endless. And if you say what is the distance in this side it is have it is endless. And if I apply the load over here, the soil stresses sometimes it may transfer up to here also. But in software world, I cannot able to define the endless situations, right? I have to go with some particular limit. That particular limit is nothing but your boundary conditions. So now I'm telling to my software that you end up over here, and then I'm just telling that if you apply any particular pressure on this, The stresses will penetrate in this direction only, but the soil will never collapse in this direction. Okay, the soil will never collapse in this direction. And similarly, in this also it is then. This is where actually, if you go back to your kinematics of machines, there you might have been studied about the subject called degrees of freedom, or else when you are putting some your free body diagrams, you know that what is the degrees of freedom. Maybe if Ashok remembers that, Dr. Matthew is our teacher, Ashok, for that.
Yes.
Okay. So here, this is what actually in the degrees of freedom that you are defining in your subject, saying that you have like a fixed boundary, like you have a boundary and you are telling that the soil collapse will not happen in this direction. Soil collapse can happen in the vertical directions. That is what you are telling for these particular boundaries. But if you just look into this particular thing, it is fixed in all degrees of freedom. Okay, again, I don't want to teach you like what is the degrees of freedom. I hope like by everyone knows it, but still if you don't know, hint me. So this is where like we were arresting in all degrees of freedom over here, that it cannot move in X direction or it cannot move in Y direction because it's a 2D. 2D will have only 2 degrees of freedom. Okay, now this is where it indicating that in Y direction I'm arresting it. But if it is like only parallel thing, in X direction I'm arresting it like this. Okay, these fixities are very, very important, and these fixities will vary from and type of analysis to type of analysis. That's where like my intention. So I was just explaining about this particular fixities in terms of like a dynamic analysis actually. So in terms of like a dynamic analysis, we will discuss it in detail. But if you really wanted to see for the initial conditions, how the boundary conditions are applied. So in your problem that you always have an option, not here, because this is just in the view that you are viewing it. You have to go to the stage construction, initial phase, and then here you can apply this particular model conditions, deformations. Here you can see this boundary X minimum is normally fixed. Normal direction is like vertical direction, it is fixed. And X maximum is also like normally fixed. X minimum is this direction and X maximum is this direction. And you can see this Y minimum is fully fixed. Y minimum is fully fixed. And Y maximum is completely free. What happens if I fix Y maximum is completely fixed is if you apply 1 ton, 2 ton, 100 ton, 1000 ton, infinite tons of a load also, your soil will never collapse. Okay, your soil will never collapse. I still do remember this kind of things that we used to do in our academics, that at the last point of time when the analysis is not running, so we used to go add some kind of rigidness over there, and then we could able to finish the analysis when
Is
the
it because
timelines
of boundary conditions, sir?
Yes. Okay, so now this is where like suppose if Y minimum is fully fixed, this is Y minimum. This is Y, right? Above it is like maximum, below this is X. This side it is like max, and this side it is minimum because negative comes, and this side it is max because positive comes over. Okay, this is where actually you have to be very, very careful about checking this particular things. And you see that whatever the load I applied it, sometimes maybe there are people will come by mistakenly, they have done something over here unknowingly, and they will come to you that whatever I do, the soil is not at all breaking, or it's any structure is not at all collapsing, because you have fixed on this particular surface. If you fixed on this particular surface, whatever you do, it will never and ever it will fail. So these are all the steps I'm giving it to you before entering into any kind of a tutorial, because make a habit of watching or observing or making note of all these particular things. Otherwise, up to a regular training sessions, what exactly the Bentley do, I can also do it from the very beginning session. I can start doing some tutorials and I can give it to you. But my intention of giving it to you is like when any analysis is running, you should be in a position to understand what it is running. Okay, so And this is where actually you can able to do, and this kind of an excavations and all that we will come a little later. Okay, but this particular thing that will be helpful for you, please be remember this slide that slowly I'm going to cover it again when we have some sheet piles in sessions and then particular time there. Okay, now you have a situations like where I have a soil and the water is here, but I would like to excavate this particular thing. During the excavations, there are two cases it can happen. Either it can be a submerged excavations, or I need to dry that particular sand and then I need to go for excavations things and all. So if I just wanted to eliminate, if I would like to make the things to be get removed on that particular things, so I have only an option saying that like just go for this particular line load, sorry, the line, not to worry. When you have this particular thing, select this particular, okay, this is not taken. Okay, when you just select any this particular soil, and if you would like to remove the water on that particular soil, then you have to make sure that, so water conditions, it's not the global level, you can just make it a simply dry. Okay, if it is dry means, now though the groundwater is over here, water level will apply to this particular layer, but for this particular layer it is always a dry condition. Bharat, you have any doubt?
No, no.
No, sir.
Okay, this is where you can able to dry this particular soil layers and all. Please be remember that when we are doing an excavation problems, this is very important thing. So when to make sure that dry of your soils and all. Yeah, a few other things are there. Slowly we will come to that particular things, but right now this is what you have to remember it for your initial cases and just look into this. Now with all these particular inputs, I hope it's all clear for you, and then I will take you to a problem statement. Now you guys have to tell me that what are all the precautions that I need to take to do this particular problem. Yeah. So now moving here, I've already shared you this particular document. I think by this time you all might have been gone through it. Okay, now settlement of a circular footing. So this is your first project. So even the documentation is also very clear from Bentley, direct from Plaxis. So you can also go through this in detail. Now this is only the image I can show you this, guys. So just by looking into the image, can you tell me like which kind of a problem it was?
Axisymmetric,
How do you say this axis symmetry?
because it's a circular footing.
Okay, yeah. Here in the geometry of a circular footing of a sand layer, they
Circular
have
footing.
given it. Okay, as it's a circular footing that you have to go it as an axisymmetric problem. Yeah, that's fine. Next, in the Plaxis that if you want to do, what are the things that you required it? Now I shared only this particular image to you. Now you guys can ask me what are the inputs that you needed to do the analysis.
The soil is there, then foundation is there, then loading is there. Three are there.
Okay.
And there is a boundary. Sand has a limit, and below sand, whether it is draining or not draining, we don't know. The dark gray one. It is a two-dimensional problem, 2D problem.
So first we have to give the borehole data, no?
Yeah.
And after that we have to give the geometry.
Yes.
Then after that
See,
we'll
remember
do.
that. Yeah. Thanks for hinting me on that. I'm little happy. So any problem if it comes, first you have to think in this direction. The geometry is fine. When you want to feed a soil, what are the things that you wanted? First you think about like 5 project properties you are thinking, and then you are deciding it's an axisymmetric problem. Then you have to go for a soil. Yeah, now into the soil actually, what are the material properties that you wanted for a soil, all these things. And when you just go for the structures, you have a foundation and you have a load. Can you please pass on me these particular two informations? And then you have to go for a mesh. When you're meshing, you already decided that this is a 6 noded or a 15 noded. So you can take care of this particular meshing and all. And to the flow conditions, you need to know about your borehole water informations, or it's a user defined water informations, only one question. And the next is like stage constructions. How do you want? Already a foundation is constructed, footing is already there. Over that I'm trying to apply the load, or you want me to construct the footing also and then you want me to apply the load. Okay, that is where in the stage constructions actually you have to be like very careful. That is why I have a soil. Over that I need to first put the footing. After putting the footing, then I need to apply a load on this, or directly you are applying the load. So now the question comes here is like, sorry, this problem can be solved in a rigid footing and as well as in a flexible footing. So first the people are trying to solve it as a rigid footing, and then we will also try to do in the same way. And for that, like we have to create one particular sand as a material properties. So now sand being a material properties, it's all a debatable topic between all the geotechnical engineers and to the lab guys and to your bosses, whatever it may be, the best quality of the sand as much as the nearest and realistic site conditions that you need to reflect over here. If you would like to reflect the nearest site conditions into your software, you should be having a more precise soil data. Okay, that's all fine. So now what I did, first thing, let me do this. Do not say, I will say it's like a rigid foundation analysis. File, project properties, I can go. Here I would like to say it's an axis symmetry and then it's a 15 noded. Okay. Now I'm clicking on the soil. Now I'll just click on this particular borehole information. Now I would like to place it snap to grid, so exactly I can able to place it. Now add how many soil layers. This is what is your first question that you will get it when you go there. And before that, okay, I have only a one particular soil layer. And what is the depth of the soil layer that you have it? Now in the geometry, they have mentioned it as like a 4 meters is a depth. So I have a 0 and then I can just go it is like -4. Okay. Now after going this particular 4, what is the borehole water level conditions it is there. So now if you just see this, a 4-meter thickness shown in the figure on the page under the sand layer of a stiff thickness, large depth, and the purpose of this is like, okay, sorry, radius is like around 5 meters that we have it. So but if you don't, they have not provided any kind of borehole informations over there, but try to make sure that the borehole information that you need to feed, so if they have given it as like a 2, but if you would like to try different values also, that's all your choice, no issues. So I'm just studying with this as a 2. 4 meters, half of this is like 2. This is the borehole conditions and all. Now this 2, I have given it when you are modeling up this particular geometry. What you have done here, they have given it as a 4 meters. I'm just going it is like -4. Now actually if I just give it as a -4, this is x direction, and -4 it comes as like 2. Okay, in the negative direction. And now the water level height, they have given it as a 2. And if I give this particular water level as 2, the water coming it is somewhere else over here. That means the entire soil is in a submerged condition. In this case, realize yourself, understand yourself. Is this reality? It is possible or not? Yeah. Someone have something? Yeah, Bharat or Vivek?
I have raised it previously while fixing the boundary conditions.
Oh, okay, fine. I didn't see that. You can unmute yourself and stop me.
I think it is not possible that head is 2 meter above the layer.
Yeah, it is not possible. So now you have to think that. So don't blindly go this. Now this is not 2, this is -2, which is makes sense. So when a person is giving you some particular data, I'm telling you that when a person mailing you data, or like when he is shared you some data, or when he shares some report with you, this kind of mistakes is pretty much common. Okay, so now you have to realize this. Now if I just go, which this is possible, but 2 is not possible at all. Okay, now now I would like to create a material property. So click on this particular materials. Now I'll just go for new. So which I'm just going to name it as a soil, and L1 I'm keeping because this is the first lesson that we are trying to learn, right? L1. And now what kind of a soil? This is where actually the questions will come in picture. I'm leaving it to you, all the engineers, because it depends upon the site to site, company to company, person to a person, and so many other factors. I don't want to comment anything on this. This is all your choice. As you are like good at it, you can decide yourself that which you would like to go. And now these are all the models that is available. Let me come with one by one. If I just go with as like a linear elastic model, linear elastic, what kind of a materials can you hint me, like what is a linear elastic model?
Hooke's law, material obeying Hooke's law.
Exactly. So the one which satisfies the Hooke's law is something called as a linear elastic model. But beyond Hooke's law, what will happen?
Elastoplastic will happen.
Yeah. So beyond the Hooke's law, actually, the elastoplastic nature will start, and from there, actually, the the material non-linear behavior will start, and then finally it will undergo some catastrophic failure, or it's a fatigue failure, or it can be an elastic failure also. Okay, so it can be of anything that depends upon the material and the situation. Okay, but this is like a linear elastic, which is something like always linear. It will never follow non-linearity. So expect this guy.
Material and water content, na?
Sorry.
Material and water content.
Water content here is helpful for you just to calculate the pore pressures.
Okay, okay.
And these
As a
particular
soil
pore
layer, we
pressures,
say something. Okay.
yeah,
Okay. Okay. Go ahead. Go ahead.
from which layer that you would like to calculate the pore pressures, it will calculate it. That's it. We are not doing any flow analysis here. Later on, we will come to that.
Okay. Go ahead. Go ahead. Go ahead.
Now it's like a linear elastic model when I select it. So though it asks me that what is your unsaturated weight and saturated weights of your soils and all. Okay. So even in this particular geometry, if you just follow the step-by-step procedures, clearly they have given it everything. Okay. See here they go with the 2, but you have to fix it onto this particular diagram because they are coming up from 4 to 0, but we going from 0 to -4. Okay, so this kind of deviations will happen from person to person. That's why we have some company standards. So some few companies where I used to work, those are all will take it as like soil surface at 0, and below that whatever it is there, that is like all the soil layers it will go. Above the surface whatever it is building, that means above X whatever it is going and all, that we consider as the structures. So it's all your wish. Again, there is a no thumb rule or nothing. You can just follow. This is just about the geometry. Okay. Now creating this particular material properties actually here. If I just go with like a linear elastic model, if I just go with the linear elastic model, I will feed the saturated unsaturated weights, and then I need to provide an Young's modulus Poisson's ratio. That's it. I can't provide any other parameters also. I can't provide any other parameters also. But we all know that we all worried about the soil analysis, and especially when we are doing a soil analysis, we need to consider the complete non-linear behavior of the soil. Okay, non-linear behavior, that means at least like plastic region, plasticity conditions of your soil that you need to consider it. Apart from elasticity, you need to consider the plasticity also. So I recommend that if you don't know any soil properties, then only choose linear elastic. But the best one is, like always, go with more column as your base model, base soil material model, and then you can choose this drainage type. Yeah, this is where actually I was supposed to be covered it little before, but I completely forgot about this. Now it's a good thing. So we have an option called as an drained, and then we have another options called as an undrained A, B, C, and non-porous materials. But as your material changes, one second. Sorry guys. Yeah. As your material changes, when you just go for a hardening soil, and now in the hardening soil, see this A and D is only possible. But if you just go for this particular Moore-Coulomb model, it is possible like A, B, and C. And moreover, like if you're just going for a soil soft grit, it's possible with only A conditions. Why? What are all these things? So first and most that we need to be known about this particular conditions also. Okay, we have an advantage with the Plaxis. After a few days, if you're opening it also, you have all the information in the right hand side pane that you can able to see this one. So when you select this as a drained conditions, the drain says that drained or a long-term material behavior. If you select it as a drain, then it is a long-term material behavior that you are analyzing it, in which the stiffness and the strength parameters, are defined in terms of an effective properties. That means if you select it as a drained here, if you go for the parameters, the stiffness and as well as the strength parameter values that you are feeding it, it should be an effective properties. If it is not an effective properties, then actually you will end up with the wrong results. Yeah. Now, the same thing when you just go with like an undrained acre condition, this is a behavior called as an undrained conditions, or we can say it is like a short-term material behavior analysis. Short-term behavior in which the stiffness and the strength of the soil are defined in terms of an effective properties, same as what you see in the drained conditions. Even in undrained conditions also, the stiffness and the strength parameters, you have to put it as like an effective parameters only. But there is an additional advantage, as this is a short-term behavior. A large bulk stiffness of a water is automatically applied to make the soil as a whole incompressible, and excess pore pressures are calculated even above the pneumatic surface. That means what will happen is, like if you select this as an undrained A condition, and in your in your borehole conditions that you are defining this as like 2 is your water level, and from 2 onwards actually your pore pressures will calculate it. But here, if you select this as an undrained A condition, it that means whatever the water compression pressure it is acting in this region, it will assume that above also the same kind of a water compression pressure is there, and then here it will calculate the excessive pore pressure conditions. That means you are indirectly telling to the software that you are calculating an excess pore pressure conditions than of reality. You are calculating an excess pore pressure conditions and all. So when to use this particular excess pore pressure conditions is what really helpful for you in terms of something like excavation analysis. Okay. Now, you are doing some kind of an excavation analysis, or not excavation, you have something land that which is really comes a very into a wet condition. Groundwater level is something too that I got to know, but the day you would like to start the constructions or before day, it was heavily rained, and because of that particular rain, your top layer or top surface is also getting wet conditions over that particular point of time. So there is a water pressure over there. So the pore pressures also need to be calculated over there also at that particular point of time. So in that particular situations, please be understand that in very clearly and then try to make it as like an undrained A conditions. This is a one example I have given, but while we are walking through multiple examples, I will also show you the realistic behavior of this undrained A conditions. Yeah. Now moving on this undrained B actually, what are, sorry, did you guys understand what is the drained and undrained A conditions? Drained is something like it's a long-term material behavior property, long-term material behavior, which requires the material properties like the stiffness and strength in terms of an effective material properties. Whereas undrained A condition is a short-term material behavior, which requires the material properties of the stiffness and strength or an effective material properties. But here in these conditions, it will consider the compressions of the water pressure above the pneumatic surface also. And then it indicates that it is calculating the excess pore pressure conditions. Any doubts on this too? Drained and undrained A?
No.
Okay.
No.
Now moving on to undrained B conditions actually. Any material, if you just see this, if you select it as an undrained B, undrained or the short-term material behavior, this is also, it is telling that it's a short-term material behavior in which the stiffness only is defined as in terms of effective properties and the strength is defined it as an undrained shear strength. If you select this one, if you go with the A and go to the parameters, here it's asking you the Young's modulus, Poisson's ratio, cohesion, friction angle and dilatancy angle. Okay, but when you just go in general and again if you just come back and select this particular undrained B behavior and go back to the parameters, here it asks you like a Young's modulus, Poisson's ratio, and then it asks you like undrained shear strength directly. There is a no cohesion, friction angle, dilatancy angle. If you know only the undrained shear strength, then it is forcing you to select only undrained B behavior. Whereas here again the Young's modulus and Poisson's ratios are like an effective properties you are feeding it, and only the strength you are telling that in terms of like an undrained shear strength. That's where like D says it. And if you just go for a C actually, undrained or the short-term material behavior, again this is the short-term material. All undrained conditions are like short-term material behaviors, that pretty much we know that, in which the stiffness and strength and are defined in terms of like an undrained properties. Now if you see this one, if I just go and select this as an undrained C, the parameters here, the Young's modulus and Poisson's ratio, I'm feeding it, this should be an undrained properties. It should be an undrained stiffness properties. If you select there it has like an undrained C condition and then you are feeding here as an effective material properties, then your problem is going to show wrong results. That's where like garbage in is garbage out. So if you give a wrong feedback, automatically the output is also wrong. But if you give a good feedback inputs to it, the output comes from this is like really good. So this is undrained A, undrained B, undrained C. And the other fourth parameter that we have it is called as a non-porous, where the non-porous material is in which the pore pressures cannot occur at all. There is a structure which is injected into your soil, some micropiles that you are feeding or something like this, where you would not at all interested to see the pore pressure calculations inside that. In that particular cases, alone to that particular structures, you can select it as like a non-porous material properties. You can select it as a non-porous material properties and all. So now you got it. There are two material behaviors. One is a long-term material behavior. Second thing is a short-term material behavior. If it is a long-term material behavior, we have only a one option that is called as a drain. If it is a long-term material behavior, then we have an options like A, B, C. And if it is a long-term material behavior, we are feeding the strength and stiffness in terms of like an effective properties. If it is a short-term A, we are feeding that in terms of like an effective properties only, but excess flow pressure will be calculated by considering the above pneumatic level also the water compressions will come in picture. But if you consider it as an undrained B conditions, only the stiffness properties that you are feeding it in terms of effective properties, but strength properties you are feeding it in terms of like an undrained shear strength. Whereas if you consider third C, long-term short-term material behavior of a C, that if you are considering it, both the stiffness and strength parameters are like an ineffective material properties that you are feeding it. And if it is like a porous material, we know that like porous material is something like your duster. It should absorb the water or anything and all. But non-porous material is something like it will not absorb the water. If there is a no water content at all, there is a no meaning of pore pressure calculations. So that's where actually it will show you that it's a non-pressure thing. Oh, okay, fine. So that's the differences between your drained, undrained A, undrained B, undrained C, and non-porous the conditions and all. Is that all clear for you? So from now onwards, when to choose which material properties, that's all again depends upon your lab guy, how he tested and sent back. So please be careful about the lab report also. When you're trying to feed your material properties, be aware about the lab report.
Thank you very much, sir.
Okay. So it makes sense for you all?
Clear.
Okay. If yes, then I would like to pass over here and then we will continue the problem in the coming session. But I really encourage we have Sunday gap in between that. If you guys would like to do the complete and end-to-end procedure of that particular problem just by following the screenshots of it, it really great.
Hello.
Thank you.
Hello.
Okay, so yeah, is there any other questions?
Yes, yes.
Yeah, but